So student, now we'll discuss the solution of this question. This is numerical answer type question. What this question is saying, a bolted assembly is tightened by 2 by 3 rotation of nut. Pitch of the thread is 1.5 mm. Okay, pitch of the thread is given. It is 1.5 mm. Okay. The stiffness of bolt is 150 mega Newton per meter. Suppose that I am denoting as kb. So kb is given 150 mega Newton per meter. Okay. Now stiffness of connecting member under compression is 75 mega Newton per meter. Okay, if you want you can convert this in Newton per mm. If you convert this in Newton per mm, 150 1 mega Newton is 10 to the power 6 Newton divided by below said meter is coming, and 1 meter is 1000 mm. So in Newton per mm it will be 150,000 Newton per mm. You can check calculation. Similarly, it will be 75. 1 mega Newton is 10 to the power 6 Newton divided by 1 meter is 1000 mm. So in Newton per mm, stiffness of connecting member will be 75,000 Newton per mm. Okay, now we have to calculate preload in the bolt when we had tightened the nut by 2 by 3 rotation. Okay, so during tightening we have rotated nut by 2 by 3 turn, can we say? So can I say during tightening number of turn of nut is 2 by 3. Okay, so how many axial moment will occur in the nut during tightening? Suppose that I am denoting as x. And how we can calculate x? If nut is taking 1 turn, then the axial moment of nut will be equal to lead, that is L. Right now nut is taking n turn, where value of n is 2 by 3. So during in n turn, axial moment of nut will be n into L, where n is number of turn made by nut during tightening and L is lead. Okay, now x we can calculate, n is 2 by 3 lead. Here pitch of the thread is given, pitch is 1.5 mm, and here number of start is not mentioned. Whenever number of start is not mentioned, we will assume that thread is single start thread, and if thread is single start thread, it means lead will be equal to 1 times of pitch, and pitch is 1.5 mm, so lead will also be 1.5 mm. So 2 by 3 into 1.5, we will get the value of x, that is axial moment of nut during tightening, and it is coming 1 mm. You can check calculation, it is coming 1 mm. Okay, now due to this tightening, suppose preload is pi. Now we already know the magnitude of preload, that is pi, in both in connecting member and bolt will be same, only nature will be different. In bolt its nature will be tensile, in connecting member it will be compressive. That I already discussed in the class, that due to preload, suppose this is bolt, I am drawing here, I am drawing just FBD, and this is connecting member, and okay, here I am just showing the cutted view of this assembly. Okay, now here due to preload, suppose during tightening preload is pi. So due to preload, pi amount of tensile force will induce in the bolt, and pi amount of compressive force will induce in the connecting member. Means what I am trying to say, suppose axial force in connecting member I am representing as PCM. So it will be equal to minus pi if we are representing tensile as plus and compressive as minus. Okay, and if axial force in bolt is due to preload is PB. Okay, PB or PBI, or here also I am writing suffix I. Okay, when I am taking I suffix, it means I am talking about preload or initial tightening load. So axial force in bolt due to preload will be equal to plus pi. Plus pi means magnitude is pi, and just plus is just representing its nature in bolt is tensile. Okay, but how we will calculate this unknown value of pi? For that we know during tightening how much axial moment we have given in the nut. During tightening, axial moment which we have provided in the nut is 1 mm, that we already know. Right now that I am representing as x. Now during tightening, the axial moment of nut will be equal to elongation of bolt will be equal to elongation of bolt during tightening This relation you should remember, during tightening or due to preload, you can say, plus always here apply mod, because we need to add both parameter which I am writing here. So simply apply mod plus compression of connecting member due to preload. And if we'll add this two parameter, we'll get the axial moment of nut during tightening. Okay, okay. So axial moment of nut during tightening will be equal to elongation of bolt due to tightening plus compression of connecting member due to preload or due to tightening, you can say, and we need to add both of these parameter. And if you are getting confused, apply mod. Suppose it is our habit, whenever length increases, generally during reflection calculation, we use plus sign. Whenever any member is in compression or length decreases, during deflection calculation we use minus sign. Okay, so but to avoid that confusion, in both the formula I have given the sign mod. Now it will not matter whether you are here connecting member is getting compressed, so whether you are taking that with plus sign or that whether you are taking that with minus sign, it will not matter, because after writing the expression of this we have to use mod sign. Okay, mod. So here both terms must get add, and to avoid any confusion, use mod sign. Now it will be equal to x. Elongation of bolt due to tightening, it will be PBI divided by stiffness of the bolt, which is KB, plus deflection of connecting member due to preload will be PCMI upon connecting member stiffness, that is KCM. Okay, on use mod. Okay, now x is equal to PBI is equal to plus PI, so PI upon KB plus PCMI is minus PI. Whether you are writing minus or plus, it will not matter, because after that we have to take mod. Now if we'll take mod, it will become x is equal to PI upon KB, and mod of minus 2 will be 2. So mod of minus PI upon KCM will be PI upon KCM. Now here KB is given in the question, KCM is given, x we already know. So from this equation we can now calculate preload PI. Okay, here x is 1 mm, that is equal to PY, we can take common PI. After taking PI common, it is 1 upon KB. KB is stiffness of bolt, that which is 150,000 Newton per mm, plus 1 upon KCM. KCM is stiffness of connecting member which is under compression due to preload. So it will be 1 upon KCM. From in this equation only one unknown PI is coming. So we can calculate value of PI after solving this equation, and it is coming 1 upon 150,000 plus 1 divided by 75,000, then inverse. It is coming 50,000 Newton. So this is the value of preload, and with this value it will come in with this same value it will come in the bolt as a tensile force. With this same value it will induce in the connecting member as a compressive force. So preload in this system is 50,000 Newton. In kilonewton it will be 50 kilonewton. In kilonewton it will be 50 kilonewton. So here value of preload PI is 50 kilonewton. Okay. So correct answer for this question is 50. Okay. So correct answer is 50 kilonewton. So student, now we'll discuss the solution of this question. This is numerical answer type question. What this question is saying, a bolted joint is used to connect two components. The combined stiffness of two components is twice the stiffness of the bolt. So combined stiffness of two component means stiffness of connecting member is given, and it is twice the stiffness of connecting member is twice the stiffness of the bolt. Okay. Now the initial tightening load of the tightening of the nut result a preload of 150 kilonewton in the bolt. Okay, so due to tightening here preload is coming. Suppose preload I am denoting as PI, it will come due to tightening, it is 15 kilonewton. In Newton it will be 15,000 Newton. Now whenever any bolted assembly or component, preload PI is coming. Okay, and if that assembly is connected with one bolted joint, here right now one bolted joint is involved. Okay, so if preload in that bolt is PI whose value is 15 kilonewton, So always the nature of preload in bolt will be of tensile nature. Means due to preload or due to tightening load, this much of tensile force will come in the bolt. Okay, and nature of this preload in the connecting member will be compressive with same value. Means in the connecting member due to tightening, this much of axial force will come with compressive nature. Okay, so this is the effect of preload. I will write this in later, but right now value of Pi is 15 kilonewton. In Newton it will be 15 Newton. Along with this, it is subjected to external tensile load of external force of 10 kilonewton, which creates further tension in the bolt. Means it is subjected to axial tensile load of external tensile load of 10 kilonewton, that I am representing as P, and definitely due to this load also tensile force will induce in the bolt, because it is tensile load. 10,000 Newton. In Newton this external tensile load is 10,000 Newton. Now the bolt is made of plain carbon steel whose tensile strength is given, it is 400 Newton per mm square. So tensile strength of the bolt is 400 Newton per mm square. Okay, now factor of safety is 3 and we have to find limiting core diameter of the bolt. Okay, now here first if we'll talk about the effect of preload in the bolt is Pi. Preload is Pi. So due to this preload, axial force will induce in the bolt, that I am representing as PBI. It will be equal to Pi and its nature will be tensile. Right now I am representing tensile with plus n and compressive with minus n. So due to preload, axial force in the bolt will be of value plus Pi. Why plus Pi? Because value is Pi and nature is tensile. So this is the effect of preload in bolt. Similarly, if you will write effect of preload in connecting member, it will be PCMI, and due to preload connecting member will be in compression, that's why I am writing minus sign, and compressive force in the connecting member due to preload will be equal to value wise it will be equal to Pi. So overall net and axial force in connecting member due to preload is minus Pi, and Pi is given in the question. But right now since strength of bolt is given, so right now our objective is to calculate total stresses or total axial force which is coming in the bolt. Due to preload, axial force which is coming in the bolt is plus Pi. Okay, plus Pi. Now we'll find the effect of external tensile load P. Okay, so now we are finding the effect of external tensile load P. Now tensile load P. Okay, now we have already discussed whenever any bolted assembly is subjected to external tensile load P, if in bolted assembly this external tensile load is acting with preload, here this external tensile load is coming with in the system with preload. In that case how much part of this P will transfer to the bolt, how much part of P will transfer to the bolt, that we can calculate. But to calculate that, first we need to calculate one factor which is known as stiffness correction factor, which I am denoting as C. So first we will find stiffness correction factor. Suppose stiffness correction factor we are representing as C. So I already discussed, if external tensile load is acting in the bolted assembly with preload, then one part of this load P will be shared by bolt and rest of the part will be shared by connecting member. Okay, connecting member. Whenever external tensile load is coming, external tensile load P is coming with preload, in that case one part of external tensile load will be shared by bolt and rest of the part will be shared by connecting member. But next question is how much part will be shared by bolt and how much part will be shared by connecting member. For that, first we will calculate one factor which is known as stiffness correction factor. What is C? Stiffness correction factor. Okay, formula to calculate stiffness correction factor is KB. KB is total stiffness of the bolt upon KB plus KCM, where KB is total stiffness of the bolt and KCM is stiffness of connecting member, or you can say stiffness of that part of connecting member which is under compression due to preload. But in question stiffness of connecting member is given, it is not mentioned it is the stiffness of which portion of connecting member. Always assume in question stiffness of that part of connecting member is given which is under compression due to preload. Okay, now this is the formula to calculate stiffness correction factor C, and if stiffness correction factor is C, then the part of this external load P which will be shared by bolt, that I am representing as PBE. PBE means axial force in bolt due to external load. Okay, so if stiffness correction factor of is C, then C part of this load P will be shared by bolt. So axial force in the bolt due to external load will be C into P, where C is stiffness correction factor, whose formula is this, and P is external load, which is external tensile load which is acting in the system, and its nature will be tensile. Okay, due to external load, if external load is tensile, so due to this external load, the force which is coming in bolt, the force which is coming in connecting member, both will be of tensile nature. Okay, now what is the part of force P which will be shared by connecting member, that I am representing as PCME, means axial force in connecting member due to external load, that will be equal to 1 minus C into P. Means C part will be shared by bolt, and 1 minus C part will be shared by connecting member. Okay, this relation I am writing when bolted assembly is connected with one bolt. Right now one bolt is involved. Okay, right now our objective is to calculate total axial force in the bolt, because we have to calculate core diameter of bolt. Okay, for that first we need to calculate what external axial force is coming in the bolt, means what axial force is coming in the bolt due to external load. Okay, for that first we need to calculate value of C. Okay, so to calculate this part, first I am calculating C. What is C? It is stiffness correction factor. Formula to calculate C is KB upon KB plus KCM. Now it is given in the question KCM is twice of KB, so it will be KB upon KB plus KCM is twice of KB, so it will be we can take KB common, KB will get cancelled, it will become 1 plus 2 plus 1, that is 3. So stiffness correction factor C is coming 1 by 3. Now the part of external load which will be shared by bolt, that I am representing as PBE, it is equal to C into P. Now value of C is 1 by 3, and P is external tensile load, whose value is 10,000 Newton. Okay, so we'll get the value of external axial force in the bolt due to external load, and it is coming 10,000 divided by 3. It is coming 3333.33 Newton. Now we can calculate total axial force in bolt. Total. Now suppose total axial force in bolt I am representing as PB. It will be equal to algebraic sum of axial force in the bolt due to preload, it plus axial force in bolt due to external load, that is PBE. Okay, algebraic sum means while doing this algebraic sum I am taking plus sign for tensile, minus sign for compressive. So PBI is axial force in bolt due to preload, that is equal to plus PI, because its nature is tensile, plus PI, and PI value is given in the question, it is 15,000 Newton. So it is plus 15,000 Newton. Similarly it is minus 15,000 Newton. But right now I require the value of PBI. It is plus 15,000 Newton plus. Now the axial force which is coming in the bolt due to external load, it is plus 3333.33 Newton. Okay, so total axial force in the bolt is 15,000 plus 3333.33. It is coming 18,333.33 Newton, and its nature is tensile. Okay, due to this tensile stress will induce in the bolt, and total tensile stress in the bolt will be, that I am representing as sigma TB, B for bolt. It will be total axial force of the in the bolt, which is PB, divided by core area of the bolt, which is AC. After calculating core area we can also calculate core diameter. So this is equal to 18,333.33 Newton divided by AC. Now since in the cross section of bolt only tensile stress is coming, so can I say right now bolt is subjected to 1D tensile stress, and whenever any system is subjected to 1D tensile stress, and if we want that our design should be safe, for that we need to ensure that 1D tensile stress in the system, right now tensile stress which is coming in the bolt is sigma TB, it must be less than equal to tensile strength of the material, which is right now SYT. But when we are doing designing, we will replace this strength by strength upon FOS, and while calculating limiting value use equal to sign. Okay, now actual 1D tensile stress in the bolt is 18,333.33 divided by AC. SYT is tensile strength of the bolt material, which is given in the question, is 400, and factor of safety is 3. So this is equal to 400 divided by 3. From this equation we will get the value, limiting value of core area of the bolt. It is coming 18333.33 into 3 divided by 400. It is coming 137.5 mm square. This is the value of core area of the bolt. Now we can calculate core diameter. Core area will be pi by 4 dc square, where dc is core diameter of the bolt. This is 137.5. So by solving this equation, we will get the value of core diameter of the bolt. It is coming 137.5 into 4 divided by pi, then square root. It is coming 13.231 mm. Okay. So core diameter of the bolt, or required core diameter of the bolt, is 13.231 mm. 13.231 mm. Now we have to give our answer nearest to round off to nearest integer. So in nearest integer, answer will be 13 mm. So correct answer, round off to nearest integer for this question is 13 mm. So student, now we'll discuss the solution of this question. This is numerical answer type question. What this question is saying, for the 3 bolt system shown in figure, yield shear strength of the material is 250 megapascal. So here directly yield shear strength is given. Suppose at shear strength I am denoting as tau f, so it is 250 megapascal. Factor of safety is 2. Okay. Now we have to find the recommended core diameter of the bolt in mm. So our objective is to find recommended core diameter, and it is subjected to the loading as shown in figure. Now suppose this load P, this load I am representing as P, it is 24 kilonewton. In Newton it will be 24,000 Newton. Now due to this load P, direct shear stress will induce in the cross section of bolt. Why? Here this is the cross section of bolt. This is the cross section of bolt. This load P will try to break the bolt from this cross section and this cross section also. And in this plane in which this load P is trying to break the bolt, this plane is parallel to this load P, and since this plane is parallel to load P, therefore due to this load P, in this plane direct shear stress will induce or primary shear stress will induce. Okay. Now how we can calculate that direct or primary shear stress? That we can calculate by calculating direct or primary shear stress in the bolt due to this force P will be total force P divided by total shear area of bolt. Total shear area of bolt. Total force P we already know, 24,000 Newton. So it is 24,000 Newton. Now what is total shear area? So you can see in one bolt, two shear area is coming, or bolt is getting shear failure from two cross section due to this load P. One bolt will get shear, one shear failure will occur in this plane, another shear failure will occur in this plane. So if we calculate shear area of one bolt, it will be, this area is pi by 4 dc square. If dc is core diameter, suppose that area I am representing as AC, core area of the bolt. So in one bolt, shearing failure is occurring from two cross section. So shear area of one bolt will be twice of AC, because one bolt is subjected to double shear due to this load P. Now total shear area. So here from two cross section shear failure is occurring. Similarly shear area of this bolt will also be 2 AC. Shear area of this bolt is also 2 AC. So total shear area will be 2 AC plus 2 AC plus 2 AC, that is 2 AC into 3. That is shear area of one bolt into number of bolt. So it is the expression of direct shear stress in the cross section of bolt. Now this direct shear stress, because here only shear stress is coming, must be less than equal to shear strength of the bolt material, which is tau f. But when we are doing designing, we will replace shear strength, that is tau f, by tau f upon Fs. And after replacing tau f by tau f upon Fs, and while you are calculating limiting value, we will use equal sign. So during design, our design equation is tau is equal to tau f upon Fs, where tau f is shear strength of the material. Now shear stress inducing in the bolt is 24,000 Newton divided by twice AC into 3, that is equal to shear strength of the bolt material. Shear strength is 250 megapascal and factor of safety is 2. So 250 divided by 2. So in this equation only one unknown, that is core area of bolt is coming. So we can calculate core area of the bolt, and it is coming 24,000 into 2 divided by 250 divided by 6. You can check calculation. It is coming 32 mm square. 24,000 divided by 6 into 2 divided by 250. Yes, 32 mm square. So core diameter of the bolt will be pi by 4 DC square. That is equal to 32. So actual core diameter, that is DC, will be equal to 32 into 4 divided by pi, then square root. It is coming 6.383 mm. Okay. So required core diameter or limiting core diameter of the bolt is 6.383 mm. 6.383 mm. Now final answer we have to give round off to 1 decimal place. So up to round off to 1 decimal place, correct answer will be 6.3 or 6.4. Okay. Okay. So correct answer for this question is 6.4 mm. So student, now we'll discuss the solution of this question. This is numerical answer type question. What this question is saying: the bolted assembly connected by 8 identical bolts as shown in figure is subjected to pressure of 6 megapascal. So number of bolt in this bolted assembly is 8. So N is 8. Okay. It is subjected to pressure small p is equal to 6 megapascal. It is given here. Now the stiffness of connecting member under compression is 2.5 times the combined stiffness of all the bolt. So suppose combined stiffness of all the bolt I am representing as KB. KCM is stiffness of connecting member under compression. So what question is saying? KCM is 2.5 times of KB, where KB is stiffness of all bolts. It is combined stiffness of all bolts. Combined stiffness of all bolts. Okay. And if KCM and combined stiffness of all bolts is given, we can calculate stiffness correction factor, that is C. Now, to ensure leak-proof joint, minimum preload in each bolt must be in kilonewton. We have to find. Here our objective is to find the limiting value of or minimum value of preload. Pi is preload in each bolt. Preload in each bolt, and we have to find limiting value of preload Pi, that which is preload in each bolt. Limiting value of preload in each bolt to ensure that our joint is leak-proof joint. Leak-proof joint. Okay. Now here suppose preload in each bolt is Pi. Our objective is to calculate limiting value of Pi. But along with this preload, this assembly is also subjected to an external tensile load. You can see here in this cross section or in this plane, pressure 6 megapascal is coming. Yes sir. Due to this pressure, one net force will come in this direction. Suppose that force I am representing as F. That force I am representing as F. And this force, or suppose if you are representing as P, you can represent. Suppose I am representing this as P. So due to this pressure, this assembly will be subjected to external force or external load P, and this load P is of tensile nature for this bolted assembly. Okay, so it is subjected to external tensile load P. And how we can calculate value of P is given? How? It is coming due to this pressure. This pressure is 6 megapascal or Newton per mm square, and this pressure is coming in this plane, and diameter of this plane is 100 mm. So area of this plane will be pi by 4 into 100 square. So 6 Newton per mm square into pi by 400 square. This much of external tensile load is acting in this assembly, bolted assembly, and it is coming pi by 4 into 100 square into 6. It is coming 47123.89 Newton. Okay. Now here preload in each bolt is Pi. Along with this, this assembly is also subjected to external tensile load P, whose value is 47123.89 Newton. Now here our objective is to ensure leak-proof joint. Now to ensure leak-proof joint, the condition is, if we want that our joint should be leak-proof joint. If we want that our joint should be leak-proof joint, for that we need to ensure that net axial force in connecting member. Suppose for tensile I am using plus sign, and for compressive force I am using minus sign. Then to ensure net axial force in to ensure leak-proof joint, we need to ensure that net axial force in connecting member must be less than equal to 0. Okay, if we are representing tensile with plus and compressive with minus, then means what we have to ensure overall, that net axial force in connecting member must be compressive. Right now we are assuming that tensile for tensile force we are using plus sign, and for compressive axial force we are using minus sign. So can I say, to ensure leak proof joint, net axial force in connecting member must be less than equal to 0. Now what we'll do here, we'll find the expression of net axial force in connecting member, and we will find that value of pi, that is preload in each bolt, which will ensure that net axial force in connecting member is less than equal to 0. Okay. Now, but for that, first we need to find the expression of net axial force in connecting member. Now I am calculating one by one. First I am finding the effect of preload. Effect of preload means what axial force will come in the connecting member due to preload. Okay. Now here preload is pi, but pi is preload in each bolt. Preload in each bolt. Okay. So preload, and we already know that effect of preload in bolt will be of tensile, and effect of preload in connecting member will be compressive in nature. Okay. So if we'll calculate what will be the effect or axial force in each bolt due to preload, that I am representing as PBI. This axial force due to preload I am calculating in each bolt. Okay. Whenever axial force we are calculating in bolt, we'll calculate in each bolt. Okay. So pi is preload in each bolt. So it is already preload in each bolt. So can I say, due to preload, axial force in the bolt will be pi, and its nature will be tensile. That's why plus pi, because due to preload, a bolt will always be in tension. So due to preload, net axial force in each bolt is plus pi, because pi is preload in each bolt. But our objective is to calculate what axial force will come in connecting member. So if we will calculate net axial force in connecting member due to preload, listen careful. Here pi is preload in each bolt. Okay. Now if any preload pi is coming in bolt, then equal and opposite axial force will come in the connecting member. What I am trying to say, if pi is preload in bolt whose nature is tensile, means can I say in each bolt plus pi axial force is coming. Now suppose any bolt is bolt 1. In bolt 1 plus pi preload is coming, plus pi axial force is coming. So due to that a minus pi axial force will come in connecting member. Minus pi means pi axial force with compressive nature. Okay. So in bolt 1 preload is pi, so due to that minus pi axial force will come in connecting member. In bolt 2 also preload is pi, because pi is preload in each bolt. Due to that also minus pi compressive force, minus pi axial force will come in the connecting member. Preload in bolt 3 is also preload in bolt 3 is also pi. Due to that minus pi with compressive force will come in the minus pi axial force will come in the connecting member. Minus sign I already using, means it I am already considering its nature is compressive. Okay. Similarly preload in nth bolt is pi. Due to that minus pi compressive force will come in, minus pi axial force will come in the connecting member. So overall total axial force in the connecting member, can I say it will be minus n pi, because when we are doing the analysis of connecting member, we will consider connecting member as single member. Okay. So due to each bolt, due to preload in each bolt, minus pi axial force is coming in connecting member. So if number of bolt is n, then total axial force in connecting member due to preload will be minus n pi, where n is number of bolt. Okay. And here n is 8, so you can also write this as minus 8 pi. Okay. So due to preload, axial force in each bolt is plus pi, and axial force in connecting member is minus n pi. Okay. Now we'll find the effect of external load P. Effect of external tensile load P. Okay. Now to find the effect of external tensile load P, first find a factor which is known as stiffness correction factor. Now what is stiffness correction factor? It is Kb, which is stiffness of bolt, but combined stiffness of bolt. Okay. Upon Kb plus Kcm. Now Kb is given in the question. It is given that Kcm is 2.5 times of Kb. So Kb upon Kb, and Kcm is 2.5 times of Kb. After solving this, we will get the value of C, that is stiffness correction factor. and it is coming 1 upon, you can check calculation, 3.5. It is coming 0.28571. It is the value of stiffness correction factor. Now if stiffness correction factor is C and total external tensile load in this assembly is P, now we have to calculate what will be the effect of this total external tensile load in each bolt. Okay, that I am representing as PBE. Okay, again whenever we are calculating effect in bolt, we are calculating in each bolt. Okay, so what is PBE? PBE is effect of external tensile load in each bolt. Okay, E for external, because since we are calculating effect of external tensile load, that's I am taking suffix E. Okay, similarly the effect of external tensile load in connecting member I am representing as PCME, means axial force shared by connecting member due to external load is PCME. Okay, now whenever bolted assembly is coming with preload, in that case what is the method to find the effect of external load P in connecting member and in bolt? If stiffness correction factor is C and external tensile load is P, then C part of the external tensile load, that is C into P, this part will be shared by all the bolt, and rest of the part will be 1 minus C into P, that will be shared by connecting member. Okay, so here you can see this is subjected to external tensile load P. Now C part of P will be C into P, so this CP part will be shared by all bolts together, but here number of bolt is not 1, it is n. So if CP part is shared by all bolts together, so the axial force shared by one bolt will be Cp upon n, because Cp is representing the axial force shared by all bolts together. So axial force shared by one bolt will be Cp upon n. Okay, and since nature is tensile, that's why I'm using plus sign. But right now our objective is not to find PB. Our objective is to find PCME, because right now I want to know what total axial force is coming in the connecting member. Okay, so if external load is P, stiffness correction factor is C, so the part of axial force P which will be shared by connecting member will be 1 minus C into P. Okay, 1 minus C, and connecting member we are considering as single member. So this in this single member, this part of axial force will come, and since external load is tensile, so its nature is also tensile. So it is axial force in connecting member. Now we can calculate overall axial force. Suppose overall axial force in each bolt is PB. So it will be PB. Due to preload, axial force in each bolt is plus PI. Okay. Due to external load P, axial force in each bolt is plus Cp by N. So total axial force in each bolt is this. But right now our objective is to calculate total axial force in connecting member. It will be PCMI, that is due to preload, plus PCME that is due to external load. So due to preload, axial force in connecting member is minus 8 pi, you can check, or minus n pi. Okay, plus due to external load, axial force in connecting member is 1 minus Cp. So it is total axial force in connecting member. Okay, now to ensure leak proof joint, leak proof joint, we have to ensure that total axial force in connecting member should be compressive, that is it must be less than equal to 0. Now its expression is, while finding limiting value we can use minus equal to sign, okay, but overall we have to ensure that it is less than equal to 0. Now PCM is minus 8 pi plus 1 minus C into P, and this must be less than equal to 0, minus 8 pi plus 1 minus C. C is stiffness correction factor, which is 0.28571, into P is the value of external tensile load, which is 47123.89 Newton, 47123.89 Newton, and this must be less than equal to 0. Okay, if we bring this part this side, it will become, this part is 4. While calculating limiting value, you can use directly equal to sign. 47123.89 into 1 minus C. C is 0.28571 it is coming 33660.12339. That should be less than equal to 8 pi. So from this, if we calculate value of pi, it will be pi must be greater than equal to, you can see in pi side greater sign is coming now. So whatever limiting value is coming, actual pi should be either equal to that or more than that. So pi should be equal to, greater than equal to this divide by 8, and if you do this divide by 8, it is coming 4207.515 Newton. In kilonewton it will be 4.207 kilonewton, and actual pi either it should be equal to this or more than this. Okay, but right now our objective is to calculate limiting value of pi. So limiting value or minimum value of pi is coming 4.207 kilonewton. Why I am saying minimum value of pi? Because actual pi should be equal to this or more than this. Okay, so preload value is coming, limiting value of preload is coming 4.207 kilonewton. Okay, preload in each bolt is 4.207 kilonewton. In last we have to round off our answer to one decimal place, so up to one decimal place it will be 4.207. If you round off this to one decimal place, it will be 4.2. So correct answer for this question is 4.2 kilonewton. Okay.